Oh, hey. So, you know all those videos that you've been seeing that the soaps manage to wipe off all that dirt and grime, those nasty stuff off from those pans? Well, there's one key ingredient that does all of this hard work. And hint, it's probably in most of the products that you've been using at this moment. So, let's get right into it. So, you know how people say that they can just go through samponification, or maybe acid base reactions, or it could be using hydrolysis instead. So, what is this ingredient that I've been talking about? You know? Like, samponification is better and
Dishwashing liquids
and no? Actually, there's just only one ingredient, just like what I said. This is called the surfactants. So, let's get right into it. Surfactants. Alright, let's just get right into it. So, if you really want to find out on how we dig through this grime and have spotless pans, well, we are going to talk about not just the surfactants, but also the rules of how it works. So take down some notes. Maybe add this to your personal memory, as you may want to be smart, like a certain someone. Anyway, usually a science non-expert or someone who's just trying to live their daily life will understand this, but we can still be just as smart as this guy here if we really tried. So I'm going to dumb it down for you, in elementary level. Alright, so let's start. Just want a minute, 내가 시대는 시간, 순진한 내 속에. Alright, so first things first, oil and water are two different things, as oil has a non-polar and water has polar properties. So basically they would never be able to mix. How's that? Is we use this principle called like dissolves like. What it means is that a non-polar mixes with only non-polar items, while polar only mixes with polar. So just example, like oil and water. However though, surfactants are a whole different thing. How though? Well, surfactants have this, what's called as a hydrophilic head. Basically, it's a polar or water attracted head. Meanwhile, their tail is a non-polar hydrocarbon chain. But basically, it's just hydrophobic. Chemically though, most surfactants are salts of fatty acids. So for example, we got sodium stearate, which is basically this. Alright, finally, we're going to the main thing. So, let's rewind a bit, Remember how I said that they have a hydrophilic head, and they have also a hydrophobic tail? Well, once we have, for example, the dirt, this dirt, we're going to like throw in some detergent and maybe we'll zoom in a bit. What it basically does is this dirt will have a head, will like mix with the surfactant where the head is still underwater, But what does the main work is the tail, as it attaches itself to the grease and starts collecting all the oil. This is the key process. Alright? So what it basically does is that the grease has all the oil or non-polar stuff that's made from by the surfactants surrounding this dirt. Once enough surface molecules that surround this chunk of grease, they form what's called as a micelle. This micelle is basically where the tail goes towards the grease and the head towards the water. Chemically, we just write it like this. Grease plus surfactant turns into grease in micelle, which is dispersed. Or this process could be called as emulsification, where we break down big oil droplets into tiny suspended droplets, which finally the water is going to wash it all away, and it's gone. Boom! Magic, you know? Magic. Alright? In short, surfactants act like tiny many helpers that grab the grease on one side and mix it with water on the other, which breaks the dirt into pieces, finally washing away, and we get a very, very clean pan. Thanks for watching.